Hello everyone, welcome to my YouTube channel for the next video. In this video, we'll see the next linear data structure, that is linked list. So now start with the linked list. Linked list can be defined as a collection of objects which are called as nodes that are randomly stored in the memory. A node contains two fields, data stored at the particular address and the pointer which contains the address of the next node in the memory. And the last node of the list contain pointer to the null. Now you can see with this diagram here, you can say as it is defined, linked list always start with the head pointer, you can say, right? And each and every node, as it is shown in the definition, that it is a collection of different nodes, and each and every node will have a information field, or you can say the data field and the next pointer field. So see that here the node having that data and the link, again that each and every node having the same fields. So first field will be the information field, or you can say the data field, and the next will be the next pointer field, or you can say the link field, right? So first node here, right? So the first node always points with this head pointer, and the last node always having the next pointer as a null. So you have to just see the diagram here. So each node holds its own data and the address of the next node, hence forming a chain like a data structure. Linked lists are used to create a tree or the graph. So always we are using for creating the graph or the trees. Okay, so this is the definition of the linked list. Now see what are different types of linked list. There are three types of linked list: singly linked list, double linked list, and circular linked list. So let's start with the single linked list. Single linked list is a collection of similar elements, and each element points to the next element. Linked list is a linear list of a specially designed nodes where each node divided into two parts. So for single linked list, each node having two parts, and the first part is known as value part and the second part is known as address of the next node. So these are the different definition of these two parts. Info field, which contains necessary informations about the items of the list to be stored and the processed. Next field, it contains the address of the next node, which this field is used to access the next data item in the order. So basically you can see always any list will be started from the head pointer. It start with the first node, then the second node, then the third node, and the till the last node. Okay, so these are the two fields. The first field is known as information field and second field known as next field. It is also known as a pointer. So it is an arrangement of a different nodes where each node points to the next node, or you can say which holds the address of the next node. Now these are the different scenarios how you are written. It is single linked list, right? Here it is written here that my list. My list means you can say the head pointer or any other things. So my list, then this is the first node, second node, third node, and the fourth node. So each node contains a value. Value means data, and the pointer to the next node in the list. So basically it is a collection of two different parts. One is a value part, another is a pointer, this next information field. Here my list is the header pointer which points at the first node in the list. So always whenever you are beginning with the linked list, we have to start one head pointer. So whether it is known as a header field, either the my list, whatever we can see. How to create the node? So this is the structure of the node. So when you write a program, so we'll always start with the structure. So that struct node int data, then node star next, and then star start, and again we are starting with the null pointer. So start is equal to null, because when you start there is no any other element in the linked list. Different operations on the single linked list. So first operation is inserting the node in the single linked list. There are three different cases, because when you start inserting the element in the linked list, there will be three cases. One is inserting at the beginning, insertion at the end, and insertion after a particular node, as you can see in the diagram. Okay, now you'll have this is the first node, this is the second node, and this is the third node. If you want to insert any new node, you have to insert in the beginning, right? So that head pointer will be begin with the first node, right? So if you want to insert any new node in the beginning, so that may be the different criteria. Again, if you want to insert any new node at the end side, so again this null pointer will be some other nodes. Same thing if you want to insert any node in a particular way, so it will be pointed to the next field. So you will just start with the insertion at the beginning here. Make the next pointer of the node point towards the first node of the list, and the start pointer point towards the new node. Now as we can see that diagram, it will be more clear here. It is written in the definition that make the next pointer of the node point towards the first node of the list, right here. So you can see this. If you are inserting the new node, earlier if you are having a list, right, so the information about that 5, 10 and 15, and if you want to add any new node, right, because earlier this head pointer will address the first node, but if you want to add the new node, so this new node will point with the head pointer. So new node will become the first node, and the head pointer will point to the new node. Okay, so as you can see in the definition here, make the next pointer of the node point towards the first node of the list, and the start pointer point towards the new node. So always you have to remember this new pointer, this pointer will points towards the new node. This is the structure after inserting the node at the beginning here. If you want to insert any node at the end, you can see the structure here, that head pointer will points to the first node, okay, and the null pointer, this null pointer will always be pointed to the last one. Okay, so here this null pointer, like the last node, will be the second last node, and if you want to add any new node, so this new node next part will be the null part, and the second last node will have the address of the new node. Okay, so this is the criteria how you are inserting the new node at the end of the linked list. Now inserting the node at the particular place, so make the next pointer of the node to be inserted point to the next node of the node, after which you want to insert the node. For example, you want to insert the node maybe after the second node, before third node, right? You have to just confirm whether you are where you want to insert the node. So this is called as previous node, this is called as next node, and this is called as new node. So as per the definition, you can see, make the next pointer of the node after which the node is to be inserted, and it will point to the node to be inserted. So this is your first node. So first node always will start from the header pointer, then the second node is will become the previous node, and this is your last node. But I want to insert any new node which will have a value of 20, and in between this 10 and the 15. So next pointer of the previous node will be the address of this new node, and again address of this new node will become the next pointer of this, the 15 node. So this is the insertion of the node in between. Now how to delete the element from the single linked list. So again the same procedure you have to follow, that deleting the element from the first node, deleting the element from the last node, and deleting the element from a particular place, or you can say intermediate nodes. Now you can see we are applying the first node like from the beginning here. So making the start pointer point towards the second node. Why? Because if you want to delete this node, right, so this will be removed. So this start pointer was earlier pointed to this particular node. But after removing the first node, now the start pointer will point to the second node. So second node will become the first node after deleting the first node. So deleting the first node using the delete keyword. So this start pointer will always point to the second node after deleting the first node. This is the procedure for deleting the node from the beginning. Now deleting the node from the last, right? Making the second last node next pointer to the null. Why? Because whenever you delete this element, because in other cases the last node always point the last pointer. So this is known as null pointer. But if I want to delete this node, so it will be removed. So second last node will point to the null pointer. So deleting the last node via the delete keyword. So this is the procedure here. After removing the last node, the second last node will point to the null pointer. And deleting the element from the particular node. For example, you will have the number of elements 4, that 5, 10, 15 and 20, and you want to remove this element, that 15, right? So make the next pointer of the node previous and the node being deleted point to the successor node and the node to be deleted, and then delete the node using the delete keyword. So basically, like, this previous node will point to the node which is not deleted here, right? So that element which is deleted from the list, right, this 15 will be deleted. So next pointer of this previous node points to the next node of the node which is to be deleted. So this is the process of deleting the element from the particular node. Another operation for the single linked list, we can search the element from the single linked list. So searching involves finding the required element in the list. We can use various techniques of searching, like linear search or binary search. In case of linked list, we are finding the elements randomly, or we can also find the element in a sequential manner. We can perform simple linear traversal techniques. Okay, then reversing the linked list. If you want to reverse the linked list, this is another operation of reversing the linked list here. We can reverse the linked list by reversing the direction of the link between two nodes, right? You can see that A, B, C and D. But if you want to reverse, you have to just reverse it. For example, A, B, so B and A. Again that B, C, it will be reversed. Then again that E. So finally it will be reversed, and the product will be, this element will be like D, C, B and A. This is the reversing of the linked list. So this is the procedure for reversal, right? As I have told you, there are three pointers P, Q and R. At any instant, Q will point to the next node and P and R will point to the node next to the P. So here that P will point to this, but it will point to this P, right? Again in the next step, again it will be swapped with the new node. So then at the end it will be reversed properly. Now the second type of linked list is double linked list. Till now we have seen the single linked list. The second type is a double linked list. Double linked list contains an extra memory to store the address of the previous node together with the address of the next node and the data which are there in the single linked list. So we are storing the address of the node, next node as well as the previous node. So basically, if you are defining the double linked list, it is a collection of different nodes and each node having three parts. The first part contains the address of previous node, second part contains the value of the particular node, and the third part contains the address of the next node. So you can see the structure of this double linked list, right? So here this is the first node, address of the previous node, second node, value node, and the third one is the address of the next node. So it can be shown in the data structure, as a linked list here, right? So these are the nodes, so each and every node having that previous node data and the next node information. If you want to add something here, write the A element, B element and the C element. So A having data value as 11, B having data value as 656 and the C having data value as 777. So this A third part means the next information field points to the next node, right? So this pointer value will be the value of this particular node, and again this pointer value will be the value of the next node. So double linked list will contain three fields: integer value, link to the next node and the link to the previous node. Structure of the double linked list, as you have seen in the diagram here, right? That previous address, next address and the data, or you can say the information field. So this is a structure. When you are creating the structure, struct node, int data and star next and previous next. So you have to just, whenever you write a program, you have to just create the structure of the double linked list. Now you can see the operations on the double linked list. As you have seen in that single linked list, we are inserting the element at the beginning, we are inserting the element at the end, and we are inserting the element in between wherever you want. The same thing if you want to delete the element from the list, right? So you have to do the same process like deletion from the beginning, deletion from the end and deletion from at the particular procedure. Okay, so this is what inserting the element at the beginning here. So if you want to see that the previous structure here, that element, this is your element here, this is the head pointer which will point to the first node. But if you want to add any new node, right? So this head pointer will point to the new node, and the next part of the new node will be the address part of the first node, and it will become the second node in the new list. This is the insertion at the beginning here. Then insertion after a node, in between if you want to add any new node. Okay, so same thing like that. This is your first node, this is your second node, this is your third node, and if you want to add any node in between the first node and the second node. So making next and the previous pointer of the node to be inserted point accordingly. So first node, next pointer of the first node will be the address of the new node, and the address of the new node will become the value of the second node in the new list. This is the entire procedure. So adjusting the next and the previous pointer of the nodes, which is the new node accordingly. So you have to just see the procedure, how you are inserting the node at the beginning, how you are inserting the node in between, and how you are inserting the node at the end. Same thing how if you want to delete the node in between, because the procedure will be same as you are deleting the element from the beginning and deleting the element from the last. So no deletion from double linked list involves changing two links, because if you want to delete the element, obviously it will be deleted from any other place. So the place of the element will be changed. We don't have to do anything because link always be next to the B here, right? And deletion of the first node or the last node is a special case, because first अगर आप delete करते हो, so after deleting the first node, the pointer will always point to the second node. If you want to delete the last node, again the pointer will point to the second node, and the last pointer, the null pointer, will always be point to the second node. So that will become the last node. Otherwise, the third case is if you want to delete the node which is in between. So after deleting that node, for this particular case, here that elements are 1, 2 and 3. But if you want to delete this element, then the last element will become the second element, and the first is always as a first place. So next pointer of the first node will point to the last pointer, last node, and the address of the last node will become the null pointer. The third type of linked list is circular linked list. Circular linked list a variation of list in which the first element point to the next element and the last element always point to the first element. Both single and double linked list can be made into the circular linked list. Circular linked list can be used to help traverse the same list again and again if it is required. As you can see in the diagram here, there are three nodes 5, 10 and 15. So here the last node always point to the first node. So if the last node points to the first node, it will become the circular linked list. So it is applicable for both the cases. One is one for single linked list and one for the double linked list. Types, because as you have seen in the definition, it is made for both single linked list as well as a double linked list. The last node points to the first node and there is only link between the nodes of the linked list. So last node always point to the first node. So there is no null pointer, always it will points to the first node. Same thing how you can make the circular linked list as a double circular linked list. So last node to the first node and there are two links between the nodes of the linked list. So here the last node, this node will always point to the first node and first node pointer always point to the last node. So this is what this is all about your circular linked list. So we can make the circular linked list in two different ways, one single linked list and the double linked list. One more thing, the operations are always happen for this circular linked list like insertion, deletion operation, searching operations. So we can follow the same process for inserting the element and deleting the elements for the circular linked list. You can see the advantage of circular linked list. The list can be traversed from any nodes. Circular lists are required data structure when we want to list to be accessed in a circle or a loop. Because if you start from the beginning, we'll go to the end and again from the end we can come back to the previous node. We can easily traverse its previous node in a circular linked list, which is not possible in the single linked list. There are different disadvantages of the circular linked list. If not traversed carefully, then we would end up in an infinite loop because there is no such end loop, nodes, because here we don't have any null value to stop the traversal. Operations in the circular linked list are complex as compared to the single linked list and the double linked list. So this is all about your linked list. Thank you.